Okay, so this video pertains to worksheet number 7, problem. So this is the ion electron method of balancing redox reactions. It does not require oxidation numbers at all. It's a completely different method. So in this method, we first have to start by matching up the substances that would appear on either side of a half reaction. So they're just going to be the ones that have elements in common. So this one has MnO4. It's for sure going to go to Mn. So that's where we start. This is our first, we're building our first half reaction. And this is a half reaction that's the complete reaction, unlike the ones I showed you in an earlier video that were just a simplified version. So here we have MnO4 minus going to Mn plus 2. So in this method, we have to start by balancing all elements that are not oxygen and hydrogen. Mn, Mn, 1 and 1, it's balanced. So then we balance oxygen by adding water molecules to the side that needs it. Sometimes this step can be skipped if there's no oxygen, but in this case, I have 4 O's on that side, which means I would need 4 water molecules on this side. Now we've obviously also introduced hydrogen, so I balance that with H plus ions, and I would need 8 H plus ions. Be careful, because it's not always going to be the same number as hydrogens you added through water, because sometimes hydrogen is part of one of these compounds. So the last step is to balance charge, and we do that by adding the electrons to the more positive side, because they are negative and they'll bring the charge down. So this has a charge of 8, positive 8, with negative 1 is positive 7, this is positive 2. So the addition of 5 electrons here will bring the charge of 7 down to 2. Okay, it's very important you get that correct, otherwise you'll have no hope of balancing the whole reaction. So now I'm going to do the second half reaction, so it's H2SO3 going to SO4 minus 2. So again, we balance the elements that are not O and H first, 1s, 1s, don't forget to do that. In this case, it's fine. We're going to balance oxygen by adding water to the side that needs it. 4O, 3O, I need 1 water molecule here. And now I have to balance hydrogen. There's 2 here, 2 there, so I need 4 H's on this side. And now I have to balance charge. This side is neutral. This side is positive 4, negative 2 is positive 2. To make it neutral, I need 2 electrons. And you see that I have the electrons on the opposite side. That's a good sign, which means I have a reduction and an oxidation now. Electrons are not balanced, so I would need to make sure that that was the case. And I'm going to multiply this whole equation by 2, they get 10, and this whole equation by 5 to get 10. And it might be a good idea, I don't have room on the board here, but it might be a good idea to actually multiply through and rewrite the equation multiplied through, and the same goes here before you add them. You're less likely to make a mistake. So I'm going to run out of room here, so I probably won't be able to get to the full answer. But what you want to do here is also remember to simplify. What I mean by that is substances that appear on opposite sides of different reactions can be canceled or subtracted. So for example, 2 times 8 is 16. Here I'm going to have 16 H's on this side. And I'm going to have 5 times 4, 20 on that side. So what you do is you have a greater number on that side than this side, so you would do 20 minus 16, which will leave you a net 4 on this side, on the product side, when you add it together. Okay? So don't forget to do that. The electrons, because they were on opposite sides, would cancel. 10 electrons in, 10 electrons out, they're gone. And waters would need to be cleaned up. I have some water on this side, some water on that side. So you have to multiply through. So here I would have 8 water molecules. Here I would have 5. So to have more on that side, I have a net of 3 on that side. So the product would have 3 water molecules. Anyway, so you've cleaned the reactions up, add them up together, and you'd be left with the answer, which I'm not going to do for you. But I do want to mention that sometimes, or in the next worksheet, you'll learn how to balance in base. And for base, you follow the exact same steps that I just did. Had the question said in base, though, at the stage where we finish this half reaction, you want to neutralize the H plus by adding the same number of OHs. So in this case, you would have added 8 OHs, hydroxide ions, which would turn into 8 H2O. every one hydroxide plus one H plus makes a water molecule. But what you do to one side, you have to do to the other, or we're going to unbalance this whole thing. So you add 8 OHs there. But because the H's have disappeared and turned into water molecules, you'll have now a net reaction in base. You'll have water to clean up though, because there's some on this side, some on that side, but you can subtract the coefficients and do that. When the same substance appears on opposite sides, you subtract the coefficients. When they're in the same side, by the way, you would add the coefficients. So you have to simplify to the point where you have nothing repeated on either side, okay? And if this was in base, I'd go ahead and do the same thing with this reaction. Do it as if it's an acid, and then neutralize my hydronium or my hydrogen ion with hydroxide in equal number. It will not affect the charge or anything else because you're adding it to both sides, so you're canceling the effect and really not impacting what you had done previously, the balance of charge and atoms and all that. Okay, that's it.